Okay, the next question, we have velocity, which has both x component and a z component in a field, same magnetic field we've had before. So I probably should indicate a vertical magnetic field. And it's an electron with this velocity, so that its QV is in the direction opposite the velocity, so the direction will be along the negative x-axis, and since the z component of the velocity is positive, the z component of the QV will be negative. So now what do we have? If we consider the x-axis to be coming this way, so the negative x-axis is in this direction, we see that QV is down and to the in the direction of the negative x-axis, but also below the x-axis. So it has a component which is in the negative x direction and a component in the negative z direction. Now, the magnetic field has no effect on the component in the negative z direction. Its only effect is on the component in the negative x direction, because of course the cross product of velocity in the negative z direction with the magnetic field is going to be 0. So we have a force which responds only to the x component of the motion. That force is going to be in the, well, let's do that. This cross with this comes out this way, so the force is in the positive y direction. The velocity vector, rather the QV vector, the velocity vector is moving the particle upward as well as in the xy plane. Okay, so the particle in the xy plane is going to experience a force in this direction. Its velocity is in this direction, so it's going to follow a circle. So we're following a circle in the xy plane, but at the same time we have this vertical velocity that's not affected by the magnetic field. And if the net force here is just the magnetic force, the vertical velocity, and this force can do no work on a velocity perpendicular to it, so that the vertical velocity is going to maintain itself, so that at the same time the particle is moving in a circle, it's also moving upward. So that we have this circular motion. Well, let's start here. We have a circular motion that's rising. So we have a helical motion. So in solving this problem, and I haven't worked out the details of the solution, but they're very similar to what we had before. Now, the magnitude of the force is the magnitude of QV cross B, and that's exactly the same as before, because the particle is an electron with the same velocity that we had in the very first problem. The K component, or the Z component, of the velocity vector, and I should clarify that, let me do so. Okay, now my statement here could be read and made sense. The K component of the QV vector here is in the B direction, so has no effect on the force. That's why the force is going to be the same as before. And of course you could run it through the whole formal calculation of the determinant with I, J, and K components and so forth to evaluate the cross product, but that is what you would find. So the result is circular motion and plane parallel to the XY plane, constant upward velocity in the Z direction, again giving you the helical motion.